All right, this is section 4.6. It's called Math Models. Really, it's applications. It's going to be best just to kind of jump right in. So all the skills that you need to solve these problems, you already have. You just need the experience working and practicing them. The only way to really get better at these type of problems is just to practice them and then to become more familiar with them. So this is one of 7. The first one says a tinsmith wants to make a small town windowsill planter from a 36 centimeter by 27 centimeter sheet of copper. She'll form it by cutting equally sized squares from each of the 4 corners of the sheet, folding the resulting flaps from the sides to make the planter, and then soldering the 4 edges. It says if she wants the ratio of the planter's length to be 2, if she wants the ratio of the planter's length to height to be 2, what will be the ratio of its length to width? Okay, so there's a lot going on there. The first thing we need to do is visually see what's going on, and then we'll set up the proportion, and then we'll be able to figure this out. So, first of all, we're going to start out with a rectangular shape. They didn't say which side represents the length and which side represents the width, so we're going to just go with the long side being the length. So this side is from here, from end to end, it's going to represent the 36. I'll just extend it. And then on the side, this side, end to end, is going to represent the 27 centimeters. Okay, they're going to cut out equally sized squares from each corner. So I'm just going to kind of draw some dotted lines to represent squares, and just imagine that all of these are the same. Now what you know from a square is that each side is the same, so let's just name a variable. Let's say that this is x. This distance is x that we're cutting off. So x, x. I'm going to put x's everywhere. Okay, so now the actual length of the planter that she's going to be making is now 36 minus 2x, okay, because we cut off a length of x from each side. So the side now that's between the 2 squares is 36 minus 2x. And then similarly, this side we're also cutting a distance of x from that. So this side would represent, I'm going to write it over here, 27 minus 2x, because x also got cut from each of those corners. 27 minus 2x. Okay. From here, we are going to determine the height. So this is the length. This side is the length. This side is the width. So when we fold this up, these sides is going to come up to a height of x. Okay. So the height, just imagine if you made a box. Okay, so you're going to be folding in these sides. And it's going to make something like a box, okay, where we have length, width, and then the height is coming from those corners. So this height is going to be, looks like x. It's the height of x. And we want the ratio of length to height. So we have length over height, and that is equal to 2. Okay, so let's plug in the length. The length we have is 36 minus 2x And then the height is only represented by a height of x from that folded up corner. And we want this ratio to be equal to 2. All right, so we're going to solve for x. So we're going to start here. We're going to multiply both sides by x to get rid of the fraction. So by x over here, by x over here. So x is going to divide out x. That's going to leave us with 36 minus 2x equals 2x. Okay. Then from there, we're going to add the 2x and move it to the other side. And that's going to leave us with 36 equals 4x. And then we're going to divide by 4. And then divide by 4, that will give us 9 equals x. So x, which represents the height, is equal to 9. Now that we know that, we can plug that in and we can figure out the ratio of length to width. Okay, so now we want to figure out the ratio of length to width. Length to width. And the length we know is 36 minus 2 times 9. Now, because we subtracted off 2 sides of 9. And then the width is going to be 27 minus 2 times 9. 36, this will be minus 18. And then this is 27 minus 18. And then when we simplify, this becomes 18. This will be 9. And when I reduce this, I also get a ratio of 2. Okay, so the ratio from height to length, or length to height, is the same as the ratio of length to width. So just 2.